Hey everybody, it's Professor Gould, and to understand biology, unfortunately, we need to understand some chemistry. And I know this makes me really sad because I'm not very good at chemistry. If anybody is like me, really not very good at chemistry, it's okay. We're only doing the very most basic chemistry in here. It's not that hard, and it's actually going to make a lot of the biology make more sense. So we really need this so we have a strong foundation for understanding the biology. So we're going to start out with the most basic stuff, which is matter. Matter is anything that occupies space and has mass. Okay, what's mass? Mass is the measure of the amount of matter in an object. Okay, that's not helpful, chemists. When you define one thing by another thing, and then that's not helpful. Okay, here, mass is stuff. Okay, matter takes up space. Everything is matter. Mass is the amount of stuff that gravity can pull on. So weight is a measure of your mass, or the mass of anything pulled on by gravity. So your weight on Earth is the same as your mass on Earth, and we measure that in grams or kilograms. In science, I know in everyday life we measure it in pounds, but in science, we use the metric system. Okay, so now, because gravity is different on different planets, mass is a more precise measure of the amount of matter in anything, because the mass of something on the moon is the same as it would be of that thing. The mass of that thing would be on Earth. So if you weighed, say, 150 pounds on Earth, when you went to the moon, you would weigh less, but you would still have the same mass. There would be less gravity pulling on it, so your weight would be less. Make sense? But on Earth, everything we're talking about is part of our, you remember the term biosphere, meaning the Earth and everything on it. And so for the purposes of biology, mass and weight are the same thing. All right, matter is composed of elements. Elements are substances that can't be broken down into other substances and maintain their characteristics. The smallest unit of each element is an atom. Atoms are made up of what we call subatomic particles. Subatomic meaning that they're smaller than the atom. But all atoms have the same subatomic particles. They have different numbers of subatomic particles. The different numbers of subatomic particles change their characteristics, which makes it a different element. So hopefully that makes sense. All right, so each element is made up of the same kind of atom, and those atoms are the same in that they have the same number of subatomic particles. In the nucleus of the atom, there are protons, which have a positive charge, shown here in green. There are neutrons, which have no charge. And then buzzing around in a cloud around the nucleus are electrons, which have a negative charge. The protons and neutrons are really big. The electrons are very, very, very small. But since they buzz around and they can sometimes be removed, they are very important in giving each atom its characteristics. So this is a helium atom, which has 2 protons, 2 neutrons, and 2 electrons. And in their standard formation, all atoms of each element are going to have the same numbers of protons, neutrons, and electrons. When we change the numbers of protons, neutrons, or electrons, we're going to change the characteristic of the atom, and it becomes either a different kind of that atom or a different element, and we'll talk about that. Hang on, that's going to make sense in just a minute. Okay, just remember that that'll be $5 for the electrons. Neutrons are free of charge. Get it? Neutrons free of charge. Get it? They have no charge. Get it? Also $5 for the electrons because they're negative. You have to give away money, so they have a negative charge. Get it? Okay. All right, so I know the periodic table is scary. It's okay. We're only going to use a very small part of it. But the periodic table shows all of the elements found on Earth, and some only made in the lab. And the periodic table tells us information about each of the elements. We're just going to worry about the top couple of rows, and in fact not most of this third row. The information in the periodic table tells us first the atomic number is the number of protons. So hydrogen has 1 proton. If it has 1 proton, it's also going to have 1 neutron and 1 electron, okay, in its standard form. The letter is the symbol. That's the abbreviation of the name. Notice that some of these symbols are 2 letters, and it's very, very, very important that you capitalize these correctly. Notice that a 2-letter symbol is always the first letter capitalized and the second letter not capitalized. This is really important because, for example, Si is silicon. But S is sulfur, and I is, let me go back here, I believe it's iodine. Yeah, iodine. So if you were to write capital S, capital I, it would mean sulfur iodine, but capital S, lowercase I means silicon. Okay, totally different things. All right, so we've got the atomic number, the symbol, the full name of the element, and then the atomic mass, which is the mass of the protons, the neutrons, and the electrons. For us, we are not going to worry about the atomic mass. In chemistry, you use that. We are not going to use that, okay? Now, except for hydrogen, normally the atomic mass is twice the atomic number plus a tiny little bit, because remember, there's protons plus neutrons, and the protons and the neutrons have about the same mass, and then the electrons are kind of tiny. So for carbon, which has a atomic number of 6, the atomic mass is 12, so 2 times 6. All right, now the most important elements in biology are carbon, oxygen, nitrogen, and hydrogen. Okay, those are the 4 that we need to worry about. And we'll come back to this and talk about how their position on the periodic table explains how many electrons they have, and that explains a lot of the characteristics of those elements. But that's going to be in another video. For now, hopefully you remember that elements are made up of atoms. Each atom has an even number of protons, neutrons, and electrons. Those are the subatomic particles. The protons and neutrons are in the nucleus. The electrons are buzzing around outside the nucleus. And in the next video, we will talk about what happens when you put 2 or more atoms together.